Hi, I'm Keon from Ace Robotics, and today I'll be talking about visual processing in FTC and in the world. What is visual processing? Robot vision refers to the capability of a robot to visually perceive the environment and use this information for execution of different tasks. Visual feedback has been used extensively for robot navigation and obstacle avoidance. In the recent years, there are also examples that include interaction with people and manipulation of different objects. Visual processing in the world. Visual processing has many applications in the world outside of FTC. Visual processing is very useful in multiple mobile phone applications, such as Snapchat. Self-driving cars also utilize the power of visual processing to make sense of the environment around them and maneuver the road. Many car companies, such as Tesla, have integrated visual processing to navigate their cars. In healthcare, visual processing can be used to analyze radiographs and determine whether or not a patient possesses a cancerous tumor or not. Object detection may be used to detect certain things in a scene and can be used to surveil an area for surveillance purposes. The back end of visual processing. This is a simplified explanation of how visual processing works under the hood. For visual processing, a neural network model is usually used. Essentially, the pixel data is passed through a neural network model and through the layers and layers of link weights before reaching the final output layer. Once the output layer is reached, the network trains itself and adjusts its weights based on the error of the final calculation in the output layer. Next, here is a diagram detailing the processes that occur in one neuron of an artificial network. It shows 4 inputs coming in, which are all multiplied by their own unique link weights and then finally added together. Once added together, their sum is found and an activation function is applied to the weighted sum to get the output of the neuron. Visual processing in FTC. Visual processing is commonly used in FTC, usually during the autonomous period of the competition where the robot must see things for itself. Luckily, there are already many libraries that simplify the process of using the power of visual processing to identify a competition piece on the field. An example is TensorFlow. TensorFlow is one of the many machine learning libraries that are out there. It is owned by Google and is capable of doing all sorts of object detection. TensorFlow is most commonly used with Python, but can also be used in many other languages, such as Java and even blocks programming. TensorFlow can also be used in C#. In FTC, TensorFlow can be used to do object detection of pieces on the competition field. Since TensorFlow has been used in the past to do object detection, there is a large online backing of documentation of past experiences and people who have used TensorFlow in the past with FTC. The benefits of using visual processing include acquiring much needed extra points during competition, being one of the few teams that use visual processing, and overall improving the robot's performance during the competition. In the scope of the world, visual processing provides a whole new field of software development and unlocks new capabilities for humanity in general. Thanks for listening. Feel free to email us if you have any questions at acerobotics15430@gmail.com.